1. What is an object? In programming, an object is a fundamental concept in object-oriented programming, OOP. An object is an instance of a class, which can contain both data and methods. Here's a basic breakdown. Data, attributes. These are variables that hold information about the object. For example, if you have a class car, attributes might include color, make, and model. Methods, these are functions that operate on the data within the object. For instance, a car class might have methods like start_engine, or drive. In a broader sense, an object can be thought of as any entity that encapsulates state, data, and behavior, methods, in a program. It allows you to model real-world entities and their interactions in a way that can be more manageable and modular. 2. What is the difference between an object-oriented programming language and object-based programming language? Object-oriented programming language, OOP. Full support for OOP principles. These languages fully support core object-oriented principles like inheritance, polymorphism, encapsulation, and abstraction. Examples: Java, C++, Python, and C# are all object-oriented languages. They support complex inheritance hierarchies, abstract classes, and interfaces. Class-based, typically, they use classes to define objects and support multiple inheritance, in some cases. Object-based programming language. Partial support for OOP principles. These languages support some object-oriented features but don't fully implement all OOP principles. For example, they may not support inheritance or polymorphism. Examples: JavaScript and VBScript are often cited as object-based languages. They use objects and allow for encapsulation and object manipulation, but may not fully support inheritance in the traditional OOP sense. Prototype-based, JavaScript uses prototypes instead of classes for inheritance. Key differences: inheritance and polymorphism. OOP languages generally support inheritance, where a class can inherit from another, and polymorphism, where methods can have multiple implementations. Object-based languages may lack these features or have them in a limited form. Class-based versus prototype-based. OOP languages usually use classes to create objects, while object-based languages like JavaScript use prototypes or other mechanisms. Complexity and flexibility. OOP languages tend to offer more sophisticated and flexible features for designing and managing complex systems due to their comprehensive support for OOP principles. In summary, while object-based languages use objects and support some object-oriented principles, object-oriented languages provide a fuller implementation of OOP features and principles. 3. What will be the initial value of an object reference which is defined as an instance variable? In many programming languages, the initial value of an object reference defined as an instance variable is typically null, or none in Python. This indicates that the reference does not initially point to any object. Here's how it works in different languages. Java, Instance variables, including object references, are initialized to null by default if not explicitly initialized. C#, instance variables are also initialized to null for reference types. Python, instance variables are not automatically initialized to none unless explicitly set. You need to initialize them in the constructor, __init___ method, if you want a specific initial value. C++, uninitialized object references, or pointers, have indeterminate values if not explicitly set. It's good practice to initialize them to null or a valid object to avoid undefined behavior. For instance, in Java. Copy code. Public class example. Private sum object obj, / initially, obj is null. In this example, obj will be null until it is assigned an instance of some object. 4. What is the constructor? A constructor is a special method in object-oriented programming used to initialize a newly created object. It is automatically called when an instance of a class is created. Here's how constructors work. Key characteristics of constructors. Initialization. Constructors are typically used to set initial values for object attributes or perform setup tasks necessary for the object to be in a valid state. Naming. Constructors usually have the same name as the class in many languages. For example, Java/C#, the constructor has the same name as the class and does not have a return type. Python, the constructor is named __init__ and is called automatically when an object is created. Overloading. Some languages, like C++ and Java, allow constructor overloading, meaning you can define multiple constructors with different parameters in the same class. Default constructor. If no constructor is defined, many languages provide a default constructor that initializes object attributes with default values. Examples in different languages. Java. Copy code. Public class person. String name. Int age. / constructor. Public person, string name, int age. This .name equals name. This .age equals age. / creating an object. Person P equals new person, Alice, 30. C#. Copy code. Public class person. Public string name get, set. Public int age get, set. / constructor. Public person, string name, int age. Name equals name. Age equals age. / creating an object. Person P equals new person, Alice, 30. Python. Copy code. Class person. Def __init___ self, name, age. Self.name equals name. Self.age equals age. Hashtag creating an object. P equals person, Alice, 30. Constructors help ensure that objects start life in a consistent and valid state, and they are fundamental to creating robust and maintainable object-oriented code. 5. How many types of constructors are used in Java? In Java, there are primarily 3 types of constructors. Default constructor. Definition: a constructor with no parameters. If no constructors are explicitly defined in a class, Java provides a default no-argument constructor. Example: Java. Copy code. Public class example. Int value. / default constructor. Public example. Value equals 0. Parameterized constructor. Definition: a constructor that takes arguments to initialize object attributes with specific values. Example: Java. Copy code. Public class example. Int value. / parameterized constructor. Public example, int value. This dot value equals value. Copy constructor. Definition: a constructor that creates a new object as a copy of an existing object. Java does not provide a default copy constructor, but you can define your own if needed. Example: Java. Copy code. Public class example. Int value. / parameterized constructor. Public example, int value. This dot value equals value. / copy constructor. Public example, example other. This dot value equals other dot value. Each of these constructors serves different purposes and allows for flexibility in object initialization. 6. What is the purpose of a default constructor? The purpose of a default constructor in Java is to initialize objects with default values. Here's a more detailed look at its role and benefits. Key purposes of a default constructor. Automatic initialization. When a class is instantiated without any arguments, the default constructor initializes the object with default values. For example, numeric types are set to 0, Boolean to false, and object references to null. Simplicity. If a class does not have any constructors explicitly defined, Java provides a default constructor automatically. This simplifies object creation and ensures that there is always a way to create an instance of the class. Support for subclassing. When a subclass is created, it implicitly calls the default constructor of its superclass, if no other constructor is specified. This ensures that the superclass is properly initialized before the subclass adds its own initialization. Legacy code compatibility. Older code or libraries that expect a no-argument constructor will continue to work seamlessly if the class provides a default constructor, ensuring backward compatibility. Example. Here's an example illustrating the default constructor. Java. Copy code. Public class example. Int value. / default constructor, implicit if no other constructors are defined. Public example. Value equals 0, / initialize value to a default. / usage. Public class main. Public static void main, string args. Example obj equals new example, / calls the default constructor. System.out.println, object value, / output, 0. In this example, if the example class did not have an explicit constructor defined, Java would provide a default constructor that initializes value to its default value, which is 0 for int. Overall, the default constructor ensures that objects are created with a consistent initial state, which can be particularly useful in cases where no specific initialization parameters are provided. 7. Does constructor return any value? No, constructors do not return any value in Java or most other object-oriented programming languages. Here are some key points about constructors. Key points about constructors. No return type. Constructors do not have a return type, not even void. Their primary purpose is to initialize a new object, and they are called automatically when an object is created. Initialization. Instead of returning a value, constructors initialize the object's attributes and set up the object for use. Automatic invocation. Constructors are called implicitly when an object is instantiated using the new keyword. They are not called explicitly and do not return anything. Example. Here's a basic example of a constructor in Java. Java. Copy code. Public class example. Int value. / constructor. Public example, int value. This dot value equals value, / initialize the object's attribute. / usage. Public class main. Public static void main, string args. Example obj equals new example, 10, / calls the constructor. System.out.println, object value, / output, 10. In this example, the example constructor initializes the value attribute of the example object but does not return any value. Overall, constructors are a special kind of method that is used for setting up new instances of a class, rather than for returning values. 8. Is constructor inherited? In Java, constructors are not inherited. While instance methods and fields of a superclass are inherited by subclasses, constructors are not. Here's a more detailed explanation. Key points. No inheritance of constructors. Constructors are not inherited by subclasses. Each class has its own constructors, and a subclass does not automatically inherit or use the constructors of its superclass. Superconstructor call. Although constructors are not inherited, a subclass can call a superclass constructor using the super keyword. This is necessary for initializing the superclass part of the object before the subclass's own initialization. Constructor chaining. In a subclass, you can explicitly call a superclass constructor from a subclass constructor. If you don't explicitly call a superclass constructor, the default no-argument constructor of the superclass is called automatically. Example. Here's an example showing how to call a superclass constructor from a subclass. Java. Copy code. Public class superclass. Int value. / constructor of superclass. Public superclass, int value. This dot value equals value. Public class subclass extends superclass. String name. / constructor of subclass. Public subclass, int value, string name. Super, value, / call the constructor of superclass. This dot name equals name. / usage. Public class main. Public static void main, string args. Subclass obj equals new subclass, 10, example. System.out.println, object value, / output, 10. System.out.println, obj.name, / output, example. In this example, the subclass constructor explicitly calls the superclass constructor using super, value. The superclass constructor initializes the value field, while the subclass constructor initializes the name field. Summary. Constructors are not inherited by subclasses. A subclass can call a superclass constructor to initialize the inherited part of the object. Each class must define its own constructors or rely on the default constructor if no custom constructors are provided. 9. Can you make a constructor final? No, you cannot make a constructor final in Java. The final keyword in Java is used to indicate that a method, class, or variable cannot be modified or overridden. However, constructors are special methods with a specific role, and the concept of final does not apply to them. Here's why. Key points. Constructor purpose. Constructors are used to initialize objects, and their purpose is not to be overridden or extended in the same way methods can be. Since constructors are not inherited, the concept of preventing their overriding doesn't apply. Final keyword. The final keyword can be used with methods to prevent them from being overridden by subclasses. It can also be used with classes to prevent them from being subclassed. However, since constructors are not inherited or overridden, the final keyword is not applicable. Usage of final in methods. While you cannot make a constructor final, you can use the final keyword with other methods in a class to prevent them from being overridden. For example, Java. Copy code. Public class example. Public final void sum method. / method implementation. Example. Here's a brief example demonstrating the use of final with methods. Java. Copy code. Public class base class. Public final void display. System.out.println, this method is final. Public class derived class extends base class. / this will cause a compile time error. / public void display. / system.out.println, trying to override. / In this example, the display method in base class is marked as final, which prevents any subclass from overriding it. Summary. You cannot make a constructor final in Java. The final keyword is used with methods and classes to restrict modification or inheritance, but this concept does not apply to constructors. 10. Can we overload the constructors? Yes, you can overload constructors in Java. Constructor overloading allows a class to have more than one constructor with different parameter lists. This enables you to create objects in different ways, depending on the arguments passed to the constructors. How constructor overloading works. Different parameter lists. Each overloaded constructor must have a different parameter list, i.e., different number or types of parameters. No return type. Constructors do not have a return type, so overloading is based purely on parameter lists. Initialization flexibility. Overloading allows you to provide different ways to initialize an object based on the parameters supplied. Example of constructor overloading. Here's a simple example demonstrating constructor overloading in Java. Java. Copy code. Public class person. String name. Int age. / default constructor. Public person. This .name equals unknown. This .age equals 0. / parameterized constructor with one argument. Public person, string name. This .name equals name. This .age equals 0. / parameterized constructor with two arguments. Public person, string name, int age. This .name equals name. This .age equals age. / method to display person details. Public void display. System.out.println, name plus age plus age. Public static void main, string args. Person1 equals new person, / calls default constructor. Person2 equals new person, Alice, / calls constructor with one argument. Person3 equals new person, Bob, 25, / calls constructor with two arguments. Person1.display, / output, name, unknown, age, 0. Person2.display, / output, name, Alice, age, 0. Person3.display, / output, name, Bob, age, 25. Key points. Different constructors. In the person class, there are three constructors, each with a different parameter list. This allows for different ways to create and initialize person objects. Flexibility. Constructor overloading provides flexibility in how objects are created, enabling different initialization scenarios based on the available data. Summary. Constructor overloading in Java allows a class to have multiple constructors with different parameter lists, enabling objects to be initialized in various ways. This provides flexibility and convenience when creating instances of a class. 11. What do you understand by copy constructor in Java? In Java, a copy constructor is a special type of constructor used to create a new object by copying the values from an existing object of the same class. Although Java does not provide a default copy constructor, you can define your own if you need to duplicate objects. Key points about copy constructors. Purpose. The primary purpose of a copy constructor is to initialize a new object with the values of an existing object. This is useful when you need to create a deep copy of an object or simply duplicate its state. Custom definition. Since Java does not automatically provide a copy constructor, you need to define one manually if you require it. The copy constructor typically takes an instance of the same class as a parameter. Deep versus shallow copy. Depending on the implementation, a copy constructor can perform a shallow copy, copying references to objects, or a deep copy, creating new instances of referenced objects. Example. Here's an example of a copy constructor in Java. Java. Copy code. Public class person. String name. Int age. / parameterized constructor. Public person, string name, int age. This dot name equals name. This dot age equals age. / copy constructor. Public person, person other. This dot name equals other dot name. This dot age equals other dot age. / method to display person details. Public void display. System.out.println, name, plus age, plus age. Public static void main, string args. Person original equals new person, Alice, 30, / original object. Person copy equals new person, original, / copy object using copy constructor. Original.display, / output, name, Alice, age, 30. Copy.display, / output, name, Alice, age, 30. Key aspects of the example. Parameterized constructor initializes a person object with specific values. Copy constructor initializes a new person object by copying the attributes of an existing person object. Usage. The copy object is created using the copy constructor, which duplicates the state of the original object. Summary. A copy constructor in Java is a constructor that initializes a new object by copying values from an existing object of the same class. It must be defined manually, as Java does not provide a default copy constructor. It can be used for creating copies of objects, which is useful in scenarios where object duplication is required. 12. What is the output of the following Java program? In Java, a static variable is a class-level variable that is shared among all instances of a class. Here's a detailed overview of static variables. Key characteristics of static variables. Class-level storage. Static variables are associated with the class itself rather than with any particular instance. This means that all instances of the class share the same static variable. Single copy. There is only one copy of a static variable per class, regardless of the number of instances created. This copy is shared among all instances. Declaration. Static variables are declared using the static keyword within a class. Initialization. Static variables are initialized when the class is first loaded into memory. They are often used to store constants or to keep track of class-level data. Access. Static variables can be accessed directly through the class name, although they can also be accessed through instances. However, it's more common and clearer to use the class name. Example. Here's an example illustrating the use of a static variable. Java. Copy code. Public class counter. / static variable. Private static int count equals 0. / constructor increments the static variable. Public counter. Count ++. / static method to get the value of the static variable. Public static int getCount. Return count. Public static void main, string args. Counter C1 equals new counter, / count equals 1. Counter C2 equals new counter, / count equals 2. Counter C3 equals new counter, / count equals 3. / accessing the static variable through the class name. System.out.println, count, plus counter.getCount, / output, count, 3. Key points in the example. Static variable declaration, private static int count equals 0, declares a static variable count that is shared among all instances of the counter class. Static variable modification, each time a new counter object is created, the count variable is incremented. Static method access, getCount, is a static method that returns the value of the static variable count. It is accessed using the class name counter.getCount. Shared value, the output count, 3 shows that the static variable count is shared among all instances, reflecting the total number of counter objects created. Summary. A static variable is shared across all instances of a class and is associated with the class itself rather than individual objects. It is useful for class-level data that needs to be consistent across all instances. Static variables can be accessed directly using the class name and are initialized when the class is first loaded. 13. What is the static method? A static method in Java is a method that belongs to the class rather than to any specific instance of the class. Here's a detailed overview. Key characteristics of static methods. Class-level association. Static methods are associated with the class itself rather than with any particular object. This means you can call a static method without creating an instance of the class. No access to instance variables. Static methods cannot access instance variables or instance methods directly. They can only access other static variables and static methods within the same class. Declaration. Static methods are declared using the static keyword. They can be called using the class name, although they can also be accessed through instances of the class. Utility methods. Static methods are often used for utility functions that do not depend on the state of any object. Common examples include mathematical functions and utility methods in utility classes. Example. Here's an example demonstrating a static method. Java. Copy code. Public class mathutils. / static method. Public static int square, int number. Return number * number. Public static void main, string args. / calling static method using the class name. Int result equals mathutils.square, 5. System.out.println, square of 5, plus result, / output, square of 5, 25. Key points in the example. Static method declaration, public static int square, int number, is a static method that calculates the square of a given number. Calling static method, the static method square is called using the class name mathutils.square, 5. This is a common practice for calling static methods. No need for object, the static method is called without creating an instance of the mathutils class, demonstrating that static methods belong to the class itself. Summary. Association with class. Static methods belong to the class and can be invoked without creating an instance. Access. They cannot directly access instance variables or methods but can access other static members of the class. Use cases. Static methods are typically used for utility functions, constants, or operations that do not require object state. Static methods provide a way to group related operations within a class that do not depend on instance data, making them useful for various utility and helper functions. 14. What are the restrictions that are applied to the Java static methods? In Java, static methods have several restrictions and limitations due to their association with the class rather than individual instances. Here are the main restrictions applied to static methods. Restrictions on static methods. No access to instance variables and methods. Static methods cannot directly access instance variables or instance methods of the class. They can only access other static variables and static methods within the class. Java. Copy code. Public class example. Private int instance var equals 10. Private static int static var equals 20. Public static void static method. //system.out.println, instance var, //error, cannot make a static reference to the non-static field instance var. System.out.println, static var, / allowed. Cannot use this keyword. Static methods cannot use the this keyword because this refers to the current object instance, and static methods do not operate on any specific instance. Java. Copy code. Public class example. Public static void static method. //system.out.println, this, / error, cannot use this in a static context. No overriding. Static methods cannot be overridden. If a subclass defines a static method with the same name and parameters as a static method in its superclass, it is not considered overriding but rather method hiding. Java. Copy code. Public class superclass. Public static void static method. System.out.println, superclass static method. Public class subclass extends superclass. Public static void static method. System.out.println, subclass static method. In this example, subclass hides the static method of superclass, but it does not override it. Cannot access non-static contexts. Static methods cannot directly invoke instance methods or access instance variables. They need to create an instance of the class or use an existing instance to access non-static members. Java. Copy code. Public class example. Private int instance var equals 10. Public void instance method. System.out.println, instance method. Public static void static method. / instance method, / error, cannot make a static reference to the non-static method instance method. Example equals new example. Example.instance method, / allowed with an instance. Cannot be used to implement interfaces directly. Static methods cannot be used to implement interface methods. They can be declared in interfaces, but these methods must be called on the interface itself, not on instances of classes implementing the interface. Java. Copy code. Public interface example interface. Static void static method. System.out.println, interface static method. Public class example implements example interface. / cannot override static methods from interfaces. Summary. No direct access to instance members. Static methods cannot directly access instance variables or methods. Cannot use this, they do not have access to this, which refers to the current object. No overriding. Static methods cannot be overridden, only hidden. Cannot directly access non-static contexts. They need to use an instance to access non-static members. Interface implementation restrictions. Static methods cannot implement interface methods directly. These restrictions are in place to maintain the static nature of static methods and ensure that they operate independently of specific instances of a class. 15. Why is the main method static? In Java, the main method is declared as static for several important reasons. Reasons for main method being static. Entry point without object creation. The main method serves as the entry point for the Java application. Since it's the starting point of execution, it must be callable without creating an instance of the class. Declaring main as static allows the Java Virtual Machine, JVM, to call it directly using the class name, without needing an object of that class. Java. Copy code. Public class Hello World.